This video will continue talk about the distinct subsequence theories, and this means ask us to count the number of distinct non-empty subsequences of S. So if the S is only include the unique character, so that means the subsequence is for every character, it has two situations. One is select it in the subsequence, another is to not select it. So for every character, it has two choice. So the total number is a power two, and is the length of this string. So because this problem includes the duplicate number, duplicate subsequence like this, like the example 3. So I need to analysis the scenario for this one, and also I need to for this one, and I think the one dimension dp is enough because this is only the first one string. So I will to copy the definition from the problem. That means for every dpi, that means it will be count the number of distinct and non-empty subsequence of S from 1 to I. So like I previous to analysis, this means I go the hypersion. Hypersion, let's assume is A. So for this A, it has a two choice. The first choice is to select all this one, all this one subsequence. For the previous I plus one subsequence, I assume it has a some number distinct non-empty subsequence like this. Let's assume all this one generates will be generated the distinct non-empty of subsequence of S from 1 to I plus 1. So the first choice for A, not select A, it is the previous subsequence generates content, and if you select A, that means this will be changed as this one. So all this one is the current operation total non-empty subsequence, but it exists some duplicate. I need to remove the duplicate. First, I will get the total. Total is previous one multiple 2. From total, I need to remove the duplicate subsequence. For duplicate, I will to generate, I will to common pattern, from common pattern to start. Let's assume for this one, and for J operation, and I have a same character for the end of operation, and between this one, and I think it has a other character. So this I operation. For this one, and if J operation, I found the character is equals this end operation character. That means from for this operation, it include non-empty subsequence in this operation. And if the if this previous operation, So for this, before this operation, and this subsequence will generate multiple subsequence. For this is for all those subsequence. If let's assume that for all this one, if it's not select this A, if it selects this A, it will generate something, some numbers subsequence, and if this subsequence not select the first A and select the end of operation A and operation A, this will be select G operation A, and this will be not select G operation A and select the I operation A. That means all this subsequence will be equals to all the later subsequence from the different A. So that means DPI will be, this means it has a 2 times repeat calculation. So I need to minus the from this range generate non-empty subsequence. It will be dpj minus 1. So that is our relationship between the previous element and the current element. And for this equation, and I will implement my code. And for previous, like the previous thinking, my code will be also use define DP and also add the virtual node for this string. DP, and also it's int new int and -1, and I will use this string with the virtual node. For this one, and I will directly go the framework. The first loop, one loop will be track every element and I++. And for this one, first I will add the previous element multiple 2. And then if I found the operation, this operation will be has the same elements with the end of operation. This one I will be minus 1, this one. And I will also to record this operation element previous for this element, whether it exists the previous index. I will use a map to save the character and the index relationship. Map new map, and then if the map has a map contains this one, the current character, I need to get the current character. Character is from I, and it's from this current element and current character previous exist. It exists, and this will be from this one, and one will get the index. Index is J. Let's see. And every time I will update this character index, and finally I will return dpn, and because it is a larger number, I need to use a model to make output the validation, and I will be mode. This will be mode. This will be mode. So right now I'm not to set the initial value, initialized value for this problem. The current element is depends the previous elements, also depends this one, j plus minus 1. That is validated. So I need to define the dp0. So for the dp0, that means it's empty. For the empty, and I need to think the empty element should define as a one distinct empty. But I add the dp0 as 1, and finally I need also to minus the empty. For this one, avoid to the overflow, I will use plus the m to check it, and I will run it. Long model, long. This will be generate a long, convert to long. So this will be long. Let me check. So that will be 7. And more test. 6, 3. I hope this will be submit passed. Submit it's passed. That means for this problem, and the DP characteristics is from the string. This is string, and the string and the array will be DP, and also because another obvious characteristic is since the results may be large, return the answer. So the large, and I need to use DP and to avoid the duplicate calculation. And for DP problem, and when I finish every DP, what I learned is I need to read back the whole thinking process, and to summarize what character will lead to the DP thinking, and also what keywords will be lead my thinking to consider DP. So I will later to summarize these characters. Thanks, and hope this. Thank you watching this video. Hope this video is helpful for you. Thanks.